So it's 10, 0, minus 1, 2, 4, 8, 4.
Yeah.
Right? So then they have this double loop, right? So you have you have for I in range length. So this just has an index going through each element of the list, and then you have the second loop doing the same. So you.
But isn't like since it's using like that length function, is that determining the length? Like that's
the number of elements in the list.
Yes, yeah, basically. Yeah. So that's what I understood. Like it's saying like okay, let's say we want 1, 2, 3.
Or 0, 1, 2, 3, 4, 5, 6. Yeah. So what happens is that so when I starts at 0, so it's pointing here.
Yeah.
And then J starts at 1. So the first element, the first comparison is here. J equals 1. Right? Now we're actually not using the I inside this function at all, right? It's only J minus 1, J minus 1, J. This is just to actually do the J loop multiple times. Right? Now then we compare element J with element J minus 1. So we say these two, and then we say if J minus 1 is larger than, or element J minus 1 is larger than element J, which it is, right? So then we put J minus 1 in 10, we put those in 10. Then we put J minus 1 in J, right? And then we put temp into J. Okay, so now the effect of that is that you get the list reordered, where you have 0, 10, minus 1, 2, 4, 8, 4. Right? Completely saturated with chalk. Yeah. Now, that's J minus 1.
Yeah.
Sorry, J equals 1. Now J equals 2. So we go here. J equals 2, and we do the same.
And it's going to do that for every number.
Yeah. So now we compare minus 1 with 10. We say, oh, 10 is also larger than minus 1. So we swap them, and you get 0, minus 1, 10, 2, 4, 8, 4. Right? Then we do the next one, where 10 is again larger. So we get 0, minus 1, 2, 10, 4, 8, 4.
It's basically going to take 10 as a basis and just keep on pushing it back. Like,
Yeah.
Okay.
Exactly. And what it ends up with is 0, minus 1, 2, 4, 8, 4, 8, 4, 10. Right? So we go 1 step, 2 steps, 3 steps, and then 4 steps. Right? Now, then you go to I equals 0. Now we do I equals 1. And we start again with J equals 1. And we do it again. So now we say, okay, oh, these two have to swap. Minus 1, 0. These? No. 2 stays, right? 2 stays, 4 stays, 8 stays, but it has to swap with 4. 4, 8, no 10. Okay. Now this is going to look a couple more times, but now every time the second one is larger than the previous one, so it doesn't swap anymore.
And then that's how it goes.
Yeah, and so you can actually make this one more. We actually had the first version was describe what it does in 10 words and give an addition of how to make it more efficient. And one of the ways is you can actually run your second loop starting from I, not from 1. You can actually start from I plus 1. Because whenever you've done the first two, you're in, it's the other way around. Anyway, at some point you know that oh yes, after the first one, you know that the last one is going to be the largest. You don't have to test that one anymore. So you can run it to len x as minus I.
Okay.
Because the first one you have to run it to the end. Second time, you don't have to, when I equals 1, you don't have to test the last one again. When I equals 2, you don't have to test the last two. You know that at the front, always. But as well, if you test for each loop, whether you've actually swapped any pair, as soon as you have one iteration where you haven't swapped anyone, then you also know you're done. Because then they're all in the right order.
Okay, perfect.
Yep.
That makes a lot of sense.
Okay. Thanks.